Welcome to ilectureonline. Here we have an interesting problem for you where we're trying to find the angle you're going to have when the force will begin to slide block number 1, M1, to the right. So we're looking for when 125 Newton force is just enough to begin to move block M1, what will be the angle here between the bracket holding M2 from sliding and the horizontal? What will be the angle theta? Keeping in mind that the static coefficient of friction is 0.2. Now what we need to do here is look at all the forces that are acting on this system. Well, first of all, we have, and let me use some red here, we know that this bracket here, which can of course can pivot in different directions, will be at a particular angle, and we know that the force will be directed along the length of this bracket. So that will be the force pulling back on M2. Now that means there's going to be a vertical component, let's call it F sub y, and there's going to be a horizontal component, let's call this F sub x. And F sub x is going to be equal to F times the cosine of the angle theta, and F sub y is going to be F times the sine of the angle theta. And again, we're trying to find what that angle will be. Next, we need to realize that there's going to be some normal forces and some friction forces. So let's find all the normal forces. Well, first of all, here we'll have the normal force 1, N1, which is going to be equal to the weight of M1, that would be M1g, plus the weight of the next block, which is M2g, but minus the vertical component of the force of the bracket, because it's going to take some of the weight of the block, so it's going to reduce the normal force, and there's going to be minus F sine theta. And let's call this N1. Then we have the normal force between the first block and the second block, let's call that N2, and that's going to be equal to the weight of this block, which is M2g, minus the vertical component here, which is F sine of theta. So those are the two normal forces. So now the friction forces. Notice that there'll be a friction force at the bottom here between this block and the surface, and a friction force between the two blocks, both acting on the bottom block because that's the only block that's going to be able to slide. The top block is going to be held in place by this bracket. So we're going to have a first friction force in this direction. Let's call that force friction 1. That's going to be N1 times mu sub s. And then we have a second friction force, call it friction force 2, which is going to be N2 times mu sub s. At the point where the block M1 is just about ready to start moving, this force right here is going to be equal to the sum of these two forces right there. So what we can do is we can set up an equation to calculate all the force in the x direction on M1, and we can find out all the sum of the forces acting on M2 in the x direction. So we're going to do that and then hopefully be able to solve for the angle by combining the two equations. So let's start with the first one. So we're going to do the first one. So the sum of all the forces in the x direction, and let's call it x sub 1, because we're only working on the bottom block right here. So the sum of all the forces in the x direction should be equal to 0 because nothing is moving yet. And so that will be equal to the force pushing to the right or pulling to the right, 125 newtons. That will be positive, minus force friction 1 and minus force friction 2, because those two forces are acting the opposite direction relative to block 1. Plugging in what those are equal to, we can then maybe put 125 on the other side. So we can say that 125 newtons is equal to force friction 1, which is N1 times mu sub s. That would be M1g plus M2g minus F sine of theta, the whole thing multiplied times mu sub s. So I took N1 and multiplied times mu sub s, and then I add to that force friction 2, and notice I moved the 125 to the other side, which makes it negative, and then multiply everything by -1 to make everything positive. Then N2, which is M2g minus F sine theta, and that would be times mu sub s. Now, since mu sub s is 0.2, if I multiply everything by 5, I can get rid of the mu sub s's. And so I can then write that 5 times this would be 625 newtons is equal to, well, we have an m1g plus 2 of these, 2 m2g's, m2g minus 2 of these, which is minus 2f sine of theta. And that's as far as I can go with this. I do know what m1g and m2g are, but I don't know what f and sine of theta is. So really what I could do is I could solve for f sine theta. I can continue on. m1g plus 2 m2g, let's work that out on the side here. So we have m1g plus 2 m2g. m1, that's 30, right? So that's 30 times 9.8 plus 2 times 20 times 9.8, which is 70 times 9.8, which is 686. 686 newtons. So if we replace this here by 686 newtons and subtract it from this side, so we have 625 minus 686, that is minus 61 newtons equals 2 f sine theta. And of course I have a minus in front of that. Divide by 2. So we have f sine theta is equal to 30.5 newtons. Notice, of course, I don't know what f is and I don't know what theta is, so I cannot yet solve for the angle, but at least I know what f sine theta is equal to. So now let me do the same thing. We're going to sum up all the force in the x direction for the top block. Now for the top block, by pulling the bottom block to the right, there's going to be effectively a force pulling to the right, and then there's going to be an opposite force pulling to the left, which is the x component of the force of the bracket. What force will be pulling block M2 to the right? It will be the friction force between these two surfaces, which will be equal to this friction force right there. So I'm creating a third friction force. Let's call this friction force 3, which is going to be equal to friction force 2, because it's going to be N2 times the coefficient of friction. And so therefore, this is going to be equal to M2g minus f sine theta, like this, times mu sub s. So that's friction force 3. Now we can go ahead and start summing up all the forces in the x direction for the top block. So the sum of all the forces in the x direction is equal to, x direction 2 for the second block is equal to 0, of course, since everything is static, nothing is moving. And we have the friction force to the right, so that would be m2g minus f sine theta times mu sub s. That's the force to the right. And the force to the left, it would be f times the cosine of theta, because that's the only force acting to the left. So it would be minus f times the cosine of theta. And it turns out I already know what f sine theta is, so I can replace this f sine theta by 30.5 newtons. I know what m2g is, I know what mu sub s is, which means that f cosine theta is equal to, when I bring this across, it becomes positive, m2g minus f sine theta times mu sub s, which means that this is equal to m2g, which is 20 times 9.8 minus 30.5. And of course, the whole thing multiplied times 0.2, which is the coefficient of static friction. So 20 times 9.8, subtract from that minus 30.5, and multiply that times 0.2. That gives me 33.1. So f cosine theta equals 33.1 newtons. So I have the f cosine theta, I have f sine theta, and so when I divide one by the other, I can eliminate f and solve for the angle theta. So I can say that f sine theta divided by f cosine theta is equal to 30.5 divided by 33.1, which means that the tangent of theta is equal to 30.5 divided by 33.1, which means that theta equals the arctangent of that same ratio, 30.5 divided by 33.1, and 30.5 divided by 33.1, take the arctangent, gives me 42.7 degrees. So 42.7 degrees, and that will be the angle that bracket will have relative to the horizontal when we're just about ready to start pulling hard enough so that M1 will begin to slide. And that's how you find that angle.